Okay, question number 20. A flask contains 0.25 moles of sulfur dioxide gas, zero point 0.5 moles of methane, and zero point 0.5 moles of oxygen. The total pressure of the gases in the flask is 800 millimeters of mercury. What is the partial pressure of sulfur dioxide gas in the flask? Okay, so if I have a flask, well, yeah, I'll just go ahead and draw it. So if I have a flask and I have some oxygen, so I'll just kind of draw some O2 molecules here. And then let's say I also have maybe some sulfur dioxide molecules. What else do we have? Methane. We also have some methane molecules in here. Oh yeah, sorry, this flask needs to be closed, right? So we're gonna close it. Close it with a lid. Okay, so these guys are, they're basically bouncing all over the place, right? We're going here, here, bumping into each other. Okay, so pressure is essentially the force that's exerted whenever they hit the side of the flask, right? Now, which of these is going to have the most pressure, or the biggest partial pressure? And essentially, if we use the ideal gas law, these should all be, approximately same size, right? Same size, same mass, right? If we just assume that they're, whoops, sorry. Well, actually, sorry. Ignore that. Essentially, what I am assuming is that their pressures are going to be proportional to the mole fraction. The pressure is basically proportional to however much gas is in the total. Okay, how do I say it? Sorry, it's kind of difficult to put into words. Basically, if I have like a lot of oxygen, you would expect that oxygen is going to contribute more to the pressure than something like, in this case, a molecule that's less, right? Now, obviously, the size of the molecule and the mass of the molecule also matters too. So that's why we're going to use moles, okay? So hopefully that makes sense. Again, if you have any questions, feel free to comment below and I can go into more detail if needed. All right, so let's go ahead and figure out my total moles of gas. So let me do that calculation here. It's going to be 0.25 plus 0.5 plus 0.5. Okay, so this is going to be my total moles. And then what I want to do is I want my mole fraction. So I'm going to have, let's see, 0.25 moles of sulfur dioxide gas. And then again, this whole thing right here is going to be 1.25. So it'll be 1.25 moles total. And then I'm going to add that to, let's see here. Wait a second, let me think here. So if this is a fraction, I need it to be equal to what? Let me think here. Partial pressure. Okay. Got it. All right, so this is going to be this mole fraction, and it's going to be out of 800. Okay. All right, I'm trying to think of what these should all equal. I actually don't like this 800 here. Let me think. Sorry, I saw these problems live. You can probably tell. Okay, so I have the mole fraction, and that's proportional to the partial pressure. Oh. Yeah. No, that's it. All you have to do is multiply by 800. Okay. I thought that was too easy, but I guess that's it. All right. So 0.25 divided by 1.25 is going to be 1/5. And my moles are going to cancel. Basically, yeah, they're going to cancel. And then you're going to multiply by 800. And you're not allowed to use wait, I'm not sure. Maybe you're allowed to use calculator. I don't remember. But anyway, it'll be 800 millimeters of mercury divided by 5. And I know that this, therefore, has to be, oh shoot, what is 80 divided by 5? What would that be? I'm thinking 160. Yeah. Because 160 plus, yes, it is 160. All right, so it's going to be 160 millimeters of mercury for the partial pressure, and that is the answer. Answer choice E. Yeah, that's the correct answer. All right, guys, so hopefully that makes sense. A little more straightforward than I was thinking. But hey, we'll take it, right? If you have any questions, feel free to comment below, and I'll see you in the next video.